Hey guys, I'm hoping I can finally wrap up the Dumont RA-113 restorations in this video. If you recall, at the end of the last installment I had wrapped up the second of the two chassis I worked on. Now I'm back to the first. When we left off with this chassis, I had removed the tuner for cleaning. Well, it's been cleaned, lubed, and reinstalled, and now I'm doing a final check. Now it's got a good picture, but sound, not so good. That's the best I can manage, and that is with the volume at 100%. Should be much better than that. So I've already done a little bit of troubleshooting. I went through the audio circuits, and just like on the other chassis, I found a couple bad mica caps in the audio circuitry and some out of tolerance resistors. Well, those have been replaced. It's actually made things a little worse. Now, why would that be? Well, I need to realign it now. I've noticed a lot of these old sets, the alignment can get, or rather, a lot of these old sets have bad audio, and they quite often benefit from an alignment. And I think part of that might be component drift, but I think a bigger part of it is people monkeying around with these coils. I think servicemen, when the sound starts getting weak, rather than troubleshooting replacing things like leaky mica caps, they start poking around with these coils. In fact, in the other chassis, one of these was mushroomed out, like somebody had jammed a larger screwdriver in here and flanged it out. So obviously somebody had gone in there and was messing around with things. So I'm going to go through the alignment procedure. Now, when I say bad mica caps, they're not like you might be thinking. With mica caps inside the IF transformers like here. Now in TVs, those are pretty rarely bad. I'm not saying it's impossible. I've worked on some Admiral sets in particular where they used the type of mica caps that often goes bad in IF transformers, which is where it's a sheet of mica with silver deposited on it, and then it's not encapsulated, it's exposed to the environment, and you get silver migration and it causes problems. No, these caps that went bad were like this 47 picofarad cap here and the 680 down there. Those are off of the detector, or well, discriminator. Those are actually filtering. This forms a pi filter, 47 picofarad to ground, 100k resistor, 680 to ground. It's actually filtering the audio signal. So if those are leaky, it's going to form a path to ground. It's going to reduce the amplitude. So, I'm going to fire up my test equipment here, sweep generator, RF generator, and scope. Yeah, unlike radios, AM radios, you really can't do this with just a VTVM and an AM generator. You really need to sweep it. I've got the instructions printed out here, and I'm going to go through the various stages here, and 5 of the stages we need to peak for response around the IF frequency of 21.75 megahertz, and then the final one is when we adjust the discriminator to get a nice slope centered around 21.75. So I'll hook up the equipment and show you guys what the waveforms look like. Okay, here's my response curve of the first stage. So signals coming in through a coupling cap to the grid of the first video IF tube. Now the schematic shows the sound pickoff is coming from the plate of that tube, but no, it's actually the plate of this stage. I'm guessing that is a production run change. Now the way it's picked off is kind of interesting. It's a wire coming through top of the chassis, actually 2 wires coming through, and looped around there. And one of the wires is just clipped off, going to nothing. And the other wire goes into the circuit. Well, that goes around to the top of the chassis and comes through a hole over here and goes to this transformer. Notice there's only 1 wire there. Well, that is forming a capacitor, gimmick capacitor, sometimes referred to. So it's 2 plastic insulated wires running parallel. One has a signal on one side and it's picked off on the other side, so there's no direct connection between the two. Two parallel wires form a capacitor, and that's how they get that very low 2.5 picofarad value. Alright, so that goes to that transformer, which feeds the grid of this tube, and then picking the signal off the plate. So signal goes into the grid here, through a couple stages of amplification, through this transformer, and then we're picking it off on this tube. This is the transformer we want to adjust. So we want it to be centered around 21.75, which it is pretty well. And we want it to not be a sharp peak, we want it to be a little bit flat-topped. Wider responses. It's FM, not AM. For FM, you need a little bit of bandwidth. The two sides here, where it's about 3 dB down, should be 21.65 and 21.85. That's where something like this comes in real handy, because I can dial those in very accurately. So there's 21.65 and 21.85. So it could be flattened out a little bit, response shifted that way a little bit. To do that, you need a tool, something like this, plastic tube with a metal slotted piece of metal in there, which will go onto this, and that bit of metal fits into the slot on the top of this. You want plastic so your hand does not affect things, and as I adjust that, see the response changes quite a bit. And there are two slugs in here, one top, one bottom, so you gotta go down to the bottom and adjust that one too. And it can get pretty frustrating to try to do this. You just gotta keep going back and forth and back and forth and back and forth to get to do what you want. Sometimes you can't get it perfect, you gotta make a bit of a compromise. So, adjusting the top, I got something kind of like that. I'll flip around to the bottom. Fiddle around with it. So typically what happens is you can get a nice broad flat response, but notice the amplitude's gone down. Well, that's alright. Better to get a wide response than a really sharp one with high amplitude, because we've got a few stages of gain here, so we can pick up the gain. Key is I want to make sure that I've got good bandwidth, because if I don't, I'm going to lose some fidelity. So there's 21.75 center, so it's nice and wide, but the center frequency is off a bit. So again, I go back to the coils and tweak them back and forth, and see if I can get this better. But even as it was before I did anything, it was actually pretty good. Now, it doesn't have to be perfect. What you don't want is it to be way, way off frequency, so you're not going to get any sound at all. So I don't think this stage is the problem. I think it's going to be one of these two guys. So I'm going to fight with this a little bit more and then move on to the other stages and pick up if I find an actual problem. Alright, moving on to the final coil now. The injection point remains the same, but the pickoff point is now after the discriminator, right here. And here is what we've got. Shape isn't too far off. However, this is the 21.75 megahertz marker. That should be at the zero crossover point, and it is not. I'll tweak this a little bit so it's right on there. So this should be a symmetrical curve, S-curve they call it, and the 21.75 should be dead in the center there, not down here. And when you do this, you're always using the smallest signal possible. Helps maintain accuracy. So low level input and small marker, and decreasing the sweep frequency can change things a bit. Notice how that response curve alters a bit. What I'm changing is the sweep time. That's how fast this generator is sweeping from the low to the high frequency, going back and forth. So as low as you can, still be able to make things out with that refresh rate. I'll do right about there. So I've got some work to do. So just like the others, there's a slug on the top, there's a slug on the bottom. Typically one alters the center frequency and the other one changes the symmetry of it. Alright, so that is looking better right there. Move things a little. So that was definitely off. Was it off enough to make a huge difference? I don't know, but we shall soon see. Adjust it on the bottom. So the center frequency alright, but symmetry is not quite perfect. That's looking better. Yeah, that's pretty darn good right there. Alright. I'm going to pop tubes back in. Remember, I removed some tubes to disable parts of the circuit while working on it. So damper tube out kills the high voltage, and tuner tubes out kills any reception from interfering with this, and the audio output tube has also been pulled. So file those back in, hook up a signal source, and see if we got better sound now. Alright, so aligning the audio IF helped out, but still wasn't as good as I'd like it to be, so I went back a little bit further and ended up aligning these two coils as well. Remember, after the tuner, we go into this, and these two coils, this first video amp stage is actually common to both audio and video, then it's picked off from here and goes through this, so I had to peak, or align rather, all 5 of these coils. That sounds much better. Next up, I'll show you that the FM radio receptor is also very, very good. But to do that, I have to disconnect my video source, because with this attached, I'm not getting any signal into the antenna. So I'll switch that out for this guy, which is nothing more than a length of coax going to an alligator clip on a center conductor, just about a 4-foot long piece of straight wire. So not much of an FM antenna, but does the job well enough. So we still have one low power TV station. I'll head over to the FM band. Oh, by the way, something interesting I don't think I've explained about this dial action. So notice when I'm in TVs, I'm tuning this, the needle's moving rather slowly. When I kick into around here, it sort of kicks into a higher gear and it starts moving faster. That's intentional. So now the stations are spaced further apart here, so they actually alter how much. That's what this complicated gizmo is for in here. They alter the ratio of turns to
because Donald Trump's coming in as a less popular president-elect, there's going to be a lot more incentives for Congress and for the states to assert more of their own jurisdiction.
A tribute with a cover of John's song Yellow Sky.
Now I'm in TV mode, so I'm getting static on the screen. I'll flip over to FM mode.
In the UK.
Yeah, which, remember, it doesn't cut power to the CRT. It's still glowing.
Shake it up. It's a Saturday morning
It's just
flashback,
cutting the brightness off.
That Alicia Keys, Justin Timberlake, beyond.
Alright, so I think that is finally going to wrap up these Dumont RA-113 chassis restorations. I hope you enjoyed it.
Wide awake.